So consider one more problem. Consider three resistors. There are three resistors and the resistance of each resistor is R, and I am also connecting these 2 points by a small wire of negligible resistance and these 2 points by small wire with negligible resistance. Then what is effective resistance of this circuit between points A and B? To find effective resistance between these 2 points, let us connect a battery of EMF V. So when you connect a battery of EMF V, then current goes through the battery. Say I is a current that is coming from positive terminal, and then I must come to the negative terminal. So here I is current here, and that's meeting a junction. So whenever it is meeting a junction, so a part of current will go through this line and a part of current will go through that line. So assume that the part that is going through this line is, let's say, I1, and the part that is going through that one becomes now I minus I1. So by symmetry we can say here, and this line and this line both are very similar, and this wire and that wire are similar. So if here it's I minus I1, then here current must be I minus I1, and through this resistor current must be I1. Now you can guess what is current through this resistor. So see here, you can apply a junction rule here. This is the junction and there are three connections, one connection, two connection and three connection. I1 is going towards the junction and I minus I1 is going away, and here let us take current in this direction. Then what must be current that is going away from this junction? So we know the sum of currents that are going towards the junction equals to sum of currents that are leaving the junction. So here the current that is going towards the junction is I1, that must be equals to current that are leaving this junction, that is I minus I1 plus that something let us take it as X. So now that X becomes 2I1 minus I. So that is the current going through this one, 2I1 minus I. That is the current going through that resistor. And we know resistance of each resistor is R. R is resistance of each resistor. R is resistance of each resistor. So now let us solve this question. So if you replace whole thing by a single resistor like this, let us say a resistance of that is R. When you maintain voltage difference V and 0, then you can write down here V equals to R times I, because I may be current going through that. So you can write down V equals to Ri. Now let us write down for this circuit also voltage equals to something times that I, then that something can be your resistance of this circuit. So now the voltage here, let us say here is V because it's connected to positive terminal, and here I am taking it as 0. Then now let us take voltage here. If it is voltage V here, then the same voltage you will see here also, because this is a wire with negligible resistance or no resistance. If there is no resistance, whatever voltage you see and the same voltage you will see here. Similarly, this point is connected to this one and the voltage here is 0 and here must be 0. Then there is a current in this line, that is I1. So you can write down voltage drop across this resistance is V minus 0 equals to small r I. V equals to R I1. Sorry, I1 is current. So let us see what is I1. You have to get everything in this form. V equals to something times I. So for that you have to replace I1 by I. So for that let us take a loop here. The loop I am taking is this one. See here, from here here, and now I'm coming back here. I'm starting from here. Let us go through this line and that line and come back here. Or you can take like this. You can take from here, go in this way and go in that way and come back to the same point. How many elements are there? This is one element, one resistor and one wire is there with negligible resistance. Then voltage across this first resistor is RI1. Then voltage across this one is R into 2I1 minus I, because the algebraic sum of voltage drops across all elements in the closed loop is 0. Then voltage across this one and that one must be 0, and voltage across this one is this, voltage across this one is this, and voltage across this wire is 0 because wire has got negligible resistance, so that is 0 and that must be equals to 0. So when you solve this equation, you will get 3I1 equals to I, that implies I1 equals to I by 3. So if I equals to I by 3, then from here you will get V equals to R by 3 times I. So you can compare these two equations. So instead of R, you get R by 3. I is I and V is V, so R is R by 3. So this is the effective resistance of this circuit. This is the effective resistance of this circuit. So look at one more circuit, that is, so you take 5 resistors here, 1, 2 and 3, and connect one more resistor like this and one more resistor like this. So now you want to compute we want to compute the net resistance of this circuit. So consider resistance of this resistor is 2 ohm and resistance of this one is 4 ohm and resistance of this one is 3 ohm and this is 6 ohm resistor and that is say 7 ohm resistor. Let us compute net resistance of this circuit. So you can calculate effective resistance of this circuit by redrawing the circuit. Let us redraw the circuit. So if I redraw the circuit, so look at 2 ohm and 4 ohm. First end of 4 ohm and first end of 2 ohm are connected to the same terminal. So let us do like this. This is, let us say this is terminal A. This is point A and let's say that's point B. Now let us take point A and let us take point B here. And first end of second resistor and first end of fourth resistor both are connected to the same point. So you'll get, so now this is your 2 ohm resistor and this is your 4 ohm resistor. Similarly, second end of 6 ohm and second end of third ohm both are connected to the single point. So now say this is 3 ohm, say this is 6 ohm, this is point B, 6 ohm. Now see, first end of third one and second end of second one both are connected. So this is second end of second resistor, so 2 ohm resistor, and that is first end of 3 ohm. Let us connect. Similarly, second end of 4 ohm resistor and first end of 6 ohm resistor are connected like this. And now from second end of fourth resistor, and there is one more connection, and from first second end of second resistor there is one more resistor like here, 7 ohm resistor. So second end of 2 ohm resistor and second end of 4 ohm resistor are connected by 7 ohm resistance. So this is second end of 2 ohm resistor and this is second end of 4 ohm resistor. Let us connect these two by a resistor. The resistance of that one is 7 ohm. Now this looks like a Wheatstone bridge, and also bridge is balanced here. So because 2 by 4 equals to 3 by 6. So 2 by 4 is 1 by 2, 3 by 6 is also 1 by 2. So the bridge is balanced. So when bridge is balanced, then we say there will be no current through this line. When there is no current through this line, then you can remove this resistor. Then you can redraw this like A, let's say B, and from here A to B, and in that there are 2 ohm and 3 ohm resistors like this, 2 ohm and 3 ohm, and similarly from A to B, here there are 4 and 6 ohm resistors. So this is 2 ohm and that is 3 ohm and that is 4 ohm, that is 6 ohm. And now 2 ohm, 3 ohm are in series and 4 and 6 are also in series. So when you redraw once again, you will get 5 ohm and here we get 10 ohm. So this is A, this is B. Now 5 and 10 both are in parallel. So effective resistance becomes now 1 by 5 plus 1 by 10. 1 by R equals to 1 by 5 plus 1 by 10. That implies R equals to 10 by 3 ohm. So this is what your resistance of this resistor, resistance of this circuit. You can also answer the same question by general process. Let us do that. Now let us take the general process and let us try to solve the same question. So now take 2 ohm resistor, that is 7 ohm resistor, and that is 6 ohm resistor. 2 ohm, 7 ohm, 6 ohm. Now there is one more resistor here, that is 4 ohm resistor. Let us connect to that point, and one more resistor. Let us connect like this. So this is 3 ohm resistor. So now this is terminal A and that is terminal, let's say, B. When you connect these two terminals to a battery of EMF V, so now potential here will be now V and potential here will be 0 now. So you can replace whole thing by a single resistor like this, by a single resistor, and let us connect that single resistor to a battery of EMF V. So current will be established in that. So you can write down V equals to Ri. So here also this battery will provide current I. If I is entering here, then the same current must come out. So you can also write down result of this circuit as V equals to Ri. So let us look at what is there instead of R, and that will be your equivalent resistance of the circuit. So now let us see. Here I is current entering here, then it's meeting a junction. So a part of current will go through this line and a part of current will go through this line. See the part that is going through this line, let us take it is I1. If that is I1, then this part must be I minus I1. So now I minus I1 is again meeting a junction. So if I minus I1 is meeting a junction, a part of I minus I1 will go through this line, a part of that goes through that line. The part that is going through 7 ohm resistor, let us take it as I2, then remaining part will go through this one, that will be now I minus I1 minus I2. And see, I1 is coming from here and I2 is coming from here, then both are meeting here. So then current that is going through this line becomes now I1 plus I2. I1 plus I2. Then I1 plus I2 is coming here and I minus I1 minus I2 is coming here. When you add this current and that current, you get once again I. So this is how we can split the currents. Now let us take some equations to compute what is I2 in terms of I and what is I1 in terms of I. So let us try to write down the equation in this form. So once you write down equation in this form, you will get answer for this one also. Let us do. So first I am taking a line. Let us take this line, straight line. The voltage across A and B equals to V. Voltage across A and B equals to V. So that will be equals to voltage across first element and voltage across second element and voltage across third element also. Now I am going in the straight path. Then you can write V equals to, then voltage across this one is 2 into I minus I1. Then voltage across this one is 7I2 and voltage across this one is 6 into I1 plus I2. So once you solve this, then you will get equation. This is 2I, and see I1s, there are minus 2I1 here and there are 6I1 here. So you get 4I1. Similarly, you get 7I2 and there are 6, that is 13I2. This is one equation. So I have taken voltage across this one and that one along this path. You can also take voltage across A and B along different path. Along different path. Let us take along this path. Take along this path. So along this path, then voltage drop again is V. So voltage across this one is once again 2 into I minus I1. Then voltage across this one 3 into I minus I1 minus I2. So once you solve this one, you get V equals to, so now V equals to, you get a 2I plus 3I, that is 5I. And similarly, if you take I1s, you get minus 5I1 and minus 3I2. So you take, this is equation 1 and that is equation 2. And you can also take one more loop. The loop is, you can take this loop. If you take this loop, then this is a closed loop, then the sum of voltage across all elements in this loop is 0. Then the voltage across this one is I minus I1. Then voltage across this one is 7I2. Then voltage across this one is minus 4I1 must be 0. So this becomes 6I1 minus 7I2 equals to 2I. So this is third equation. So let us solve these three equations. If I solve these three equations, or let us equate 1 and 2. If I equate 1 and 2, and 5I and there is 2I, then when you cancel 2I, then you get 3I here, 3I. And similarly 4I is there, 4I1, and here it is minus 5I1. Let us write down that. So here 2I from first equation, 2I plus 4I1 plus 13I2 equals to 5I1 minus 5I1 minus 3I2. So let us take this I here, then you get 3I. bring this minus 5i1 here, you get 9i1, and bring this one also here, you get plus 16i2. So this let us take as a fourth equation. So now let us solve 3 and 4 equations. Once you solve 3 and 4 equations, let us solve 3 and 4 equation. So from 3, this is equation 3. From 3 you can write down I equals to 3i1 minus 7 by 2i2. Similarly, from 4 I equals to 3i1 plus 16 by 3i2. So once you solve these two equations, let us remove this equation from that equation. If I remove this second equation from this, then your answer will be, so I minus I will be 0, and 3i1 minus 3i1 will be 0. Then this minus that, it will be minus 7 by 2 minus 16 by 3, I2 becomes 0. Then it means I2 is 0. If I2 is 0, so now I2 is 0, then let us take first equation. Then first equation, from the first equation we can write, first equation is this, then I2 is 0, then you can write 2i v equals to 2i plus 4i1, and I2 is 0. So when I2 is 0, so the first equation will be this. Then let us take third equation. From third you can write, this is the third equation, 6i1, and this is 0, that equals to 2i. So this implies I1 equals to 1 by 3i. So let us substitute this I1 in this equation. So now v equals to 2i plus 4 by 3i. So that implies v equals to 2 plus 4 by 3i. That implies v equals to 3 into 2 is 6, then 6 plus 4 is 10, 10 by 3i. So now let us compare this one with the general equation that I wrote here, that is v equals to ri. So then v is there and I is there instead of I, then instead of r you got 10 by 3. So resistance of this circuit is 10 by 3 ohm. So this is the answer. Consider one more problem. So here in this problem there are many resistors. So consider one resistor here, and one more here, and one more here, and one more there, and like this. It's infinite, like infinite number of resistors are there, and the resistance of this one is say 1 ohm, and all these resistors, resistance of all these resistors is 1 ohm, and here it's 2 ohm resistor, and it's 2 ohm, and it's 2 ohm. Now the whole connection, sorry, these terminals say A and B are connected to a battery of EMF 6 volts. Now we need to estimate what is effective resistance of this circuit, and second, what is the current that is going through this second 2 ohm resistor. That is the question. First one is you need to compute net resistance of this circuit, and second one is current going through this resistor. So let us do the first question. Let us take first question. Let us compute net resistance of this circuit. So you take terminal A and terminal B. So 1 ohm and 2 ohm. 1 ohm, 2 ohm, and there are many like infinity. So if this is the situation, so assume that effective resistance of the whole circuit is X. If effective resistance of the whole circuit is X, if I block only this part, look at, I am blocking this part. If I block this part and I make these two terminals, if I make this is one terminal and that's one terminal, then the right part will be similar to the original problem once again. The right part will be very similar to the whole system. So if net resistance of the whole system is X, then resistance across these terminals, let's say C and D, must also be X. So now I can replace the resistance of whole whole system across C and D is also X, and the same resistance you will see across A and B also. So now this is A and that is B. There is 1 ohm resistor here and there is 2 ohm resistor here. Now I am replacing whole thing by a single resistor of resistance X. Effective resistance of the whole circuit must also be X. So now 2 and X both are in parallel, then effective resistance of this one, this is 1 ohm, and effective will be 2x by x plus 2. Then effective resistance across A and B once again will be X, and that equals to 1 plus this part because both are in series once again. So now X equals to now X equals to 1 plus 2x by x plus 2. So that implies x square plus 2x equals to x square plus 2x equals to x plus 2 plus 2x. You can cancel 2x and 2x, then your equation becomes x square minus x minus 2 equals to 0. So once you solve this equation, then your x value will be x equals to, so this is like ax square plus bx plus c. Then the solution for that is minus b plus minus root of b square minus 4ac by 2a. If you use that equation, so you get minus b means instead of b minus 1 is there, so you get 1 plus minus root of b square means 1 square plus 4, instead of a 1 is there, and instead of c is minus 2, so you get b square minus 4ac, so you get 2 here by 2. So this implies x equals to 1 plus minus root, this is 9, then root 9 is 3 by 2. So this implies x will be, you have two solutions here, 1 minus 3 by 2, that gives you minus 1 ohm. That cannot be correct answer because resistance of any wire cannot be minus. And next solution is 1 plus 3 by 2, that is 4 by 2, that is 2 ohm. This can be the correct solution. So now effective resistance of the whole circuit is 2 ohm. Effective resistance of whole circuit is 2 ohm. Now let us compute next question, that is current going through 2 ohm resistor when you connect 6 volt battery. So now we are connecting to 6 volt battery across these two terminals. Let us see what current will go through 2 ohm resistor. So now we know that the effective resistance of the circuit between C and D terminal is 2 ohm, and also across A and B also 2 ohm. So now you can replace, let us say this is A terminal and that is B terminal. So this is 1 ohm and this is 2 ohm, and effective resistance of the circuit between C and D is also 2 ohm. Let us take 2 ohm. Now you are connecting 6 volts battery to this part. When you connect 6 volt battery to this, then net current going through this circuit will be, because 2 ohm and 2 ohm both are in parallel, effective resistance of this combination is 1 ohm and that 1 ohm and this 1 ohm both are in series. So net resistance of the circuit will be, now it is 2 ohm, then current becomes now 2 by 3. Sorry, voltage is 6 volt and net resistance is 2, then it means you get 3 ampere. So 3 ampere current will go through this 1 ohm resistor, and the same current must reach the negative terminal of the battery. It's 3 ampere and there's also 3 ampere, and it's meeting a junction, and junction is very similar because here it is 2 ohm and here is also 2 ohm. Then exactly, if 3 ampere is coming here and two connections are very similar, then half part will go here and half part will go there. So it means 1.5 amp will go here, 1.5 ampere will go there. Then resistance, then current going through this resistor is 1.5 ampere. So look at one more problem. So this is the problem. So now here resistance of each wire. So this wire and this wire and this wire, every wire, resistance of each wire, resistance of each wire is here. Let's say R. Then we want to find effective resistance between A and B terminal. These are A and B. These are 2 points. And you need to find effective resistance of the circuit between these 2 points, and resistance of each line is, say, R. So find equivalent resistance between the two diagonally opposite points A and B. So when you connect a battery here, the general procedure, let us connect a battery here. Once you connect a battery here, if current I is going through this, then I must come back. So look at from here, this I is this current is meeting a junction. There are 3 lines, and if you look at these 3 lines are very similar. For example, if you take this line, so 1 line, 2 line and 3 line going to negative terminal, and if you take this line, 1 line, 2 line and 3 line going to negative terminal, and take this line, 1 line, 2 line, 3 line going to negative terminal. Take any line, 1 line, 2 line, 3 line going to negative terminal, one line, 2 line, 3 line going to negative. Any if you take any direction, the lines, 3 lines are similar. So when lines are similar, then if I is current going here, then exactly I by 3 will go through this line, and I by 3 will go through this line, then I by 3 will go through this line. Similarly, when it is receiving here, then I by 3 comes from here, I by 3 will come from here, then I by 3 will come from here. Now look at this I by 3, let us look, and it's meeting a junction here. Once again there are 2 connections. Once again there are 2 connections here. When there are 2 connections, see this connection 1 and this is 1 connection, and this connection and that connection again are similar, because this connection after this it will go here and again going to negative terminal, and this connection after going here and it will go and again come to negative connection. In all aspects these 2 connections are similar, so exactly I by 6 will go here and I by 6 will go there. So now if V is voltage difference, now you can take voltage across A and B is V, then that V equals to, then voltage across this one R into I by 3, and voltage across this one and voltage across that one. So I 6 plus R into I by 3. Voltage across this one is this, across this one is that, across this one is this one. Then you can write V equals to, so when you add all these currents, so you get R into 5I by 6. So that implies V equals to 5 by 6 Ri. So if you compare this equation with the general equation, that is V equals to Ri, then instead of R you got 5 by 6 R. So this will be our answer. So let us take one more question. So now we want to compute effective resistance of this circuit between A and B. Resistance of each resistor is R. So resistance of each resistor is R. Now when you connect a battery here, let us say V is voltage across the battery. So see, by symmetry you can say this line and this line both are similar. So if I is current that is coming from the battery, then I must come to the negative terminal. So I is meeting a junction and there are three lines. If I1 is going here, then the same current must come here, I1, because these two lines are similar. And then remaining current I minus 2I1 will go through this line. If I is coming here, I1 is going through this line, then the same current must received by negative terminal through this connection, because this one and that one again both are similar. So you get I1 here and here also I1, and through this one you get I minus 2I1. So now you see very clearly that there is no current through this line and there is no current through that line. If there is no current through this and there is no current through that, you can remove these two. So when you remove these two, and this R and that R both are in series, and these are in series, and these are also are in series, then we get this R and this R. Then 2R is the effective resistance. You can write this is 2R, and this line is 2R, and this line is also offers 2R resistance. Say this is A and that is B. So 2R, 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 then effective resistance becomes now 3 by 2R. That implies R equals to 2R by 3. You can also solve the same question by general process. See that one. If V is voltage across A and B, then you can write down voltage across A and B equals to voltage across this one plus that one. Voltage across this one is R into I minus 2I1. Voltage across this one is R into I minus 2I1. So it is 2R into I minus 2I1. Voltage across this one equals to voltage across this plus that. So this is what that. You can take a loop here. If you take loop here like this, or you can take loop like that, this loop you take, then voltage across all elements in the closed loop, the sum of voltage across all elements in a closed loop is 0. Then voltage across this one is R into I1. Voltage across this one is also R into I1. Let us take 2R into I1. Then voltage across this one and this one both are similar, and voltage across this one is minus R into I minus 2I1. And this is also same. Let us take here 2, and that must be 0. So you can take 2R common, then you get I1 minus I plus 2I1 equals 0. That implies 3I1 equals to I, then I1 equals to I by 3. So if I1 equals to I by 3 from here, then V equals to 2R I minus 2I by 3. It is 2I by 3. So now V equals to 2R into, it is 3I minus 2I, that is I by 3. That implies V equals to 2R by 3I. So if you compare this equation with general equation, you can write down R equals to 2R by 3. So this is the answer for this question. You can this is the answer you will get when you take the general process. So